So we're going to get started, and today we're going to talk about MvRx. In case you were curious, it's pronounced MvRx. It's not MvRx. And while we're on that topic, FYI, Airbnb is spelled with a capital A and no others. So something I see a lot, and just wanted to clarify that. So before I get started, just want to introduce myself briefly. My name is Gabriel Peal. I'm a software engineer at Tonal. Tonal is a fitness startup. We make basically it's a gym that mounts to your wall like a TV, and personal trainer, fitness community, and a bunch of other stuff. But I used to be at Airbnb, where I was working on Android, native infrastructure, various libraries such as Lottie, and also worked on some React Native stuff while I was there as well. Okay, so let's talk about MvRx, because that's why you are all here. So MvRx is an Android architecture library, and it's built on top of Android Jetpack. Now, this is a really important point. We knew when we set out to build MvRx that we wanted it to stay pretty close to what Google was doing. Jetpack is an amazing suite of libraries. It's evolving really fast, and it's frankly really, really good. So we didn't want to redo the work they're doing. We wanted to build on top of it. We also knew that we wanted to make it Kotlin only. One of the things that's great about Jetpack is it solves a lot of fundamental challenges with Android development. But it was designed to work in a Java and Kotlin world. So they have some KTX extensions, but we wanted to make sure that we wanted to allow ourselves the flexibility of designing this to be Kotlin only. And we wanted it to be simple. We wanted anyone to be able to pick it up and learn it without having to understand a full philosophy, without taking an academic course on functional programming or reading an entire textbook on some philosophy. We wanted it to really just be built to get stuff done, because at the end of the day, all of this stuff we're doing, the Android lifecycle, all of these libraries, it's just a means to an end to ship a really high quality product. So we came up with MvRx, and we tried it with a little beta at Airbnb. This was at the beginning of last year. We worked with 14 engineers across a few different product teams who tried it out. And it turns out they really liked it. In fact, 13 out of 14 of the first people who used it, this is pre 1.0. We hardly had any documentation or anything, but 13 out of 14 of them gave it an 8 out of 10 or higher. And frankly, the 1.7 was because we didn't have as much documentation, and it's really continued at about that trend today. I just don't have updated numbers. So once we finished this pilot, we decided to allow anybody at Airbnb to use it. And since then, the growth has looked like this. In fact, today, basically 1 year after it really started rolling out, you can see there's 7.1 last year, about 40, 50 screens after that pilot. And today, there are almost 600 unique screens in the Airbnb app built on MvRx. So super production ready. It's used from a variety of screens, from the core search experience to the listing details page and everything in between. I've since moved to Tonal. I've been there for almost a year now, and we use MvRx for everything as well. Totally different form factor, different product. It's in the fitness space. Our most complex screens, the core workout experience, also built in MvRx. So it's ExoPlayer, audio insertions, dynamic streaming video, streaming audio, complex calculations, interacting with hardware. It all pipes through MvRx, and it works just as well. Okay, so before I show it to you, let's lay the foundation. We're all familiar with the Android lifecycle. It's pretty complicated. It has a lot of, each lifecycle exists for a reason, but it's a lot of work. And again, this is all just a means to an end to ship a high quality product. So Google built Jetpack view models, which really helped to simplify this. With view models, the lifecycle looks like this. And they created a place where you can put your business logic that will last for the logical lifecycle of a screen, rather than the view lifecycle, which gets destroyed and recreated across configuration changes, switching between apps, etc. So they really separated those two, and they've given us a great place to do our work. Okay, so now we have that. Let's talk about a screen. Like, what actually is a screen, really, is the real question. Well, you can think of it in two different ways. Imagine we're building this screen. This is the core workout experience for Tonal. You can think of it as the sum of all of the individual actions that have happened from the beginning of time to right now. Or you could think of a screen as a function of the current state of the world. These are two different principles to think of it. Let's talk about that first one. Here's two situations. You have a blue circle followed by a gold star and a couple other shapes in one world. And then in another world, you have the same shapes with the same colors, but in a different order. And so all you know is the state of the world, or the sequence of events that got you to right now. And you ask yourself, are they the same? And the answer is maybe. You really don't know. So imagine, for example, there's a view that, or the workout experience, you can pause it, or you can pull the handle to start working out on Tonal. What if you pause the screen and then pull the handle while it's paused? Well, how does it know, like, to show the timer or like do something special? Or you just know that it's paused and the handle is pulled as one state class. So let's start thinking about a screen as just a pure function of state. It's that simple. And now that we've seen MvRx rolled out across Airbnb and Tonal, and other companies like Dropbox and a number of others are starting to adopt it as well, we've seen that this notion of a screen being a pure function of state is actually being consistent and allowing us to scale our apps in a simple and consistent way across a variety of different use cases. So here's Airbnb, this screen, also a function of state. Twitter, function of state. Yelp, also a function of state. Great, so now I'm gonna hop out of my slides and we're gonna go into Android Studio and we're gonna actually take a look at this. So, let me fix the emulator. Let's start with a little simple counter, right? Everyone's favorite Hello World demo. When you click it, the number goes up. We lost something. Displays. Management. Unplug it and plug it back in again. Oh, I see. I probably want a mirror for this one, don't I? Arrangement and mirror. Great. You good now? Awesome. Okay, so we have an emulator here, and when you click it, the counter goes up. Really, really simple. So what is the state class for the screen? Well, let's start with Kotlin here. So we have, basically this is, right now I have a shell of this same fragment, but I've removed most of the code. Okay, so we want to remodel it now. So we'll make a Kotlin data class. Seems reasonable. Data class counter state. And then let's give it a property. So we know we're going to have a val count. It's an int, and we're going to initialize it to 0. Okay? Now let's basically just tag this class as compatible with MvRx. So we're going to make it extend MvRx state. This is actually an empty interface, and it's used for ProGuard configs. It's really not used for anything else. So we have class counter state, and now we want to somehow render our screen based on this state. So now we need a view model. Raise your hand if you used Jetpack view models before. Okay, awesome. So most of you, I'll go quicker then, because it seems like most of you have used it. So our view model is going to be our place where we do our business logic, where we want to increment that count. And the fundamental difference between a normal Jetpack view model, where you might have a series of live data properties that you observe on individually, is that in MvRx, your MvRx view model is generic on your state class. It owns a single state class, and all you do is subscribe to state changes or modify it from within the view model. Okay, so let's take a look at that. So we're going to make a class counter view model, and we're going to give it an initial state. So initial state, counter state. I'll explain this in a second. And then it's going to extend MvRx view model. Okay, awesome. So to get started, this is actually all we need to create our view model class. Now, counter state is kind of interesting. That initial state property, it's actually passed in by MvRx. So MvRx will either initialize your state for you, or it can actually restore certain properties from your state from save instance state, which I'll show you in a second. Okay, so now we have our fragment. We need to get this view model. So in Jetpack, you would use maybe a lazy property like in view model providers to get an instance of your viewModel class that's scoped to either your fragment or your activity. Now, the reason you use the provider from Jetpack is so that if you rotate the screen, it will reassociate your new fragment with your original viewModel, which is how they enable you to have that really clean and simple lifecycle that survives for the entire logical lifecycle of your screen, rather than just from the view lifecycle. But MvRx makes that a little bit easier. So this is one of the things that we did because the MvRx is Kotlin first. So first, we're just going to make our fragment extend MvRx fragment, base MvRx fragment, like that. And then immediately, the class is going to turn red because there's one function we have to implement, and it's called invalidate. Invalidate is similar to render, if you're familiar with React. This will get called anytime the state for any of your viewModels changes. And all you need to do is re-render the screen. So we're going to implement that in a second, but now at least the class will build. So now we need to get our viewModel. So we're going to make a private val viewModel. It's of type counter viewModel. And now we're going to use a property delegate called by fragment view model, just like that. Great. So now what this has done is it's wrapped those viewModel providers. It's going to give you a new instance or an existing one, depending on the state of your screen. It's automatically going to subscribe to any state changes in a lifecycle-aware way and call invalidate whenever the state changes. Now we need to get our state. And so the way you do that with MvRx is with state. And for simplicity, since this is a common pattern, we like to use the expression body syntax for this. So I'm going to set invalidate equal to with state. We're going to pass in viewModel, and it's going to give us our state to render, just like that. And if we look at the layout here, there's one text view called counter view. So we'll just say counter view dot text equals state dot count dot toString. Great. And if we run this, it should work. Although we haven't actually incremented our count, we do get the initial state. So this has already happened. We've gotten our viewModel, we've subscribed to changes, and we've rendered the state to the screen. Now all we have to do is actually increment our count. So here we go. Let's create a function called fun increment count. And then the opposite of with state is a function called set state. So if we call set state, we can only call this from within the viewModel. So we know that any changes to state have to happen from inside of your viewModel. Now, I hope you can see this little pop-up here, but the type of this state is counter state as the receiver, no parameters, and a return type of counter state. And the reason it's this way is you basically just want to get the current state of the world, modify it in some way, and then return the new state. So our counter state is a Kotlin data class. So here we can just call copy count equals count plus 1. That's it. And similar, because this is a common pattern, we'll use the expression body syntax again, and we can do this in one line of code. Now all we have to do is wire it up to a click listener on view created, counter view dot set on click listener, view model dot increment count, just like that. All right. Now if we click it, it works. We never had to told our UI to invalidate or rebind. It just did the right thing. We can prove that the lifecycle works correctly here. If we rotate, we still get 6. So that is in fact working with nothing else. Now, let's make this a little bit fancier. We'll go to our activity. This is just the activity that inflates that fragment. It really doesn't do anything fancy. Let's just go ahead and duplicate this. So now we'll have 2 counters on screen. Great. So counter 1, counter 2. They're independent. Pretty easy, but they're both on screen. Now, what if we wanted to share data between these fragments? I put them both on screen for simplicity, but this could be multiple fragments in a flow. It could be across different parts of your app, just within the same activity. Here, we change the scope from fragment to activity viewModel. Get the import. And then now when we rerun it, both of these fragments will get the same viewModel. All we have to do is change that one word. And as of MvRx 1.1, which we're going to release probably this week, there's parent fragment viewModel and target fragment viewModel as well. So you can really get specific with your scopes. Okay, this is great. So we've made some progress here. Now I want to show you a little recipe of what we might do if we wanted to, let's say, fetch some asynchronous data. So we'll say actually, we'll do one little quick thing here. So now we have count. Let's say we want to actually display whether the count is even. We can give our state class a body here. And here we can add properties inside of our state class. And we call these derived properties. So we can say val is even equals count mod 2 equals 0. So our data class here is immutable. So every time we emit a new one of these state classes, all of the derived properties we know will be up to date because it's calculated for that instance of the state class. And since it's immutable, it's going to just work. We don't have to do anything else. So here, if we let's add is even to it. So we have count even. There we go. We'll run that. There we go. So they're both up to date, they're both really accurate. This is super convenient because now our entire screen is represented with an immutable data class. It's super easy to test, and it basically just works. All right, so now let's do something a little bit more complex. Let's fetch something from a server. So we'll say fetch data, like this. And I'm gonna fake this for now, but we'll do it for real in the next demo. So we'll just do observable dot just loaded. So we have a string observable here, and then we'll delay the subscription for 2 seconds, and we'll subscribe on the IO thread. And so now this is an interesting position we're in. So we're going to fetch some asynchronous data, and it's going to take 2 seconds. What you would normally do with a view model is something like this. Val data string, make this a nullable string, and then val is data loading, boolean equals false, and then val data error, and then maybe that's a throwable, and then that's nullable. So now we have 3 properties, and it becomes a mess here. So this is, get this, so it's going to look something like this. So it's going to be like subscribe, and then we have our on next, and we have our on error, and then we have to, add it to a disposable, which we have to dispose it on clear. And what if we retry it and we had an error and then it succeeds? We have to remember to actually clear the error in the on next. It's crazy. And how many of you have fetched something asynchronously, started to do this, and be like, you know what, it's not worth it. I'm not actually going to handle all the loading states and error states. I know some hands went up, and I'm sure that some of you are just too shy to admit that. Okay, so MvRx is going to help with this. So let's go back to our slides for a second, and let's think about this stream. So we have an Rx stream of observable, and it starts out with nothing, right? We haven't done anything, so it's uninitialized. In MvRx, we created a sealed class with 4 types: uninitialized, loading, success, and fail. It's generic on the success type. The success type wraps the successful value, and the failure type actually has the exception that it failed with. So what we've created with MvRx is an extension function on observable that takes the stream of data of type T, and it maps it to a stream of async T. And it automatically handles the loading and failing, all that kind of stuff for you. So here we can see if we have a stream, when we subscribe, it will emit loading. And then for every successful value, it will emit success wrapping that value. Similarly, if it fails, it will just emit failure wrapping the exception. Or if it fails and then succeeds, you will get the failure, and then it'll just emit a success. But it'll probably go through a loading state in between. Okay. So let's take a look at this. So instead of subscribe, we're going to use a function called execute. Execute does this mapping, and then also handles the disposing of it in uncleared. So we don't have to deal with disposables ourselves. So we're going to do copy. Now here we can remove all of these, except now our data, instead of nullable string, it's async string. And then it's going to be uninitialized. Great. So that's what we have to do there. And then we just say data equals it. And that's all we have to do. This is going to handle everything for us. So now, instead of increment count, let's just say we're going to fetch data. And then in the text, let's go ahead and, for simplicity, we'll just do state.data.class.java.simple name. We're going to render the class name. Let's go ahead and run that. There we go. So we got the loading states, we got the success states. You can use instance of checks or whatever it is you want in there to actually do the right thing in the UI, but you know that your state is correct, and that's the important thing. Now we can make this easier. Instead of showing success, let's actually just show that successful value. So let's go in here, and now what we're going to do is we're going to call state.data, and we're just going to call it like a function. So it's null. I'll explain this in a second. Loading. And loaded is the value from our observable here. So we've taken async when we've overloaded the invoke operator. So you can call it like a function, and it returns a nullable form of whatever generic type your async is. So that you can just invoke it, and if it's successful, you'll get the value. Otherwise, you'll get null. All right. So these are some of the core fundamental building blocks of MvRx. Let's take a step back and put it all together and do it again in a real app. Before that, I'm going to show you one more thing because I forgot. So let's go back to our activity here. We'll just remove the second counter. We're going to do something. We'll go back to increment count, counter fragment, and then we'll do state.count like that. Okay. So we've proven that we handled the rotation case correctly, right? Here we go. We'll rotate like that. But there's a little known thing in Android where it can actually kill your app and give you a save instance state, and then it will actually restore your app in a new process with just that save instance state bundle to restore from. People usually just think of the rotation case, but this is a subtle difference, and it can be really helpful in bringing your users back to that state. So I'm going to go into developer options here and say, okay, no background processes allowed. So when I switch back, you'll see it's actually restarting the app from scratch. If we increment the counter, switch back to settings, each time, new process, we're back at 0. This makes sense because this is not the rotation case. This is literally a new Linux process in the purest sense. Well, MvRx can help us with that. So we're going to go up to our state class, and we're going to annotate this property with persist state. You can do this on any serializable or parsable field. And now when we increment the count, switch apps, come back, new process, same state. So this is really, really nice if you have something like an ID. These are usually used things to refetch your data. You don't want to store all of your data there, but something like an ID for a details page would be really, really handy. So this is another one of those conveniences where we didn't want to rebuild everything Jetpack was doing. We just wanted to add a layer on top. All right, back to the slides for a second. I have one more slide in the whole presentation, but plenty more work to do, don't worry. Let's adopt a dog, okay? We're going to put this together, and we're going to build an app for a dog adoption agency right now. It has 3 screens. It has a list of dogs. It's going to fetch it asynchronously. It has a dog detail page, and you can adopt it. It does some paperwork, and then you adopted this really cute dog. So these are our 3 screens, and we're going to go ahead and build it right now. So the first thing I have here, let's go ahead, and some stuff might still be red because I haven't built the project. But first thing we want to do is understand, let's take a look at what we have here. So using some Jetpack stuff, MvRx is very unopinionated with the rest of the app that you have. So here I'm using data binding and navigation components. At Airbnb, we very heavily use epoxy. It works really well with that. You could use it with litho. You can use it with literally anything that you want because MvRx solves a very specific problem, and it's really easy to integrate with pretty much any architecture that you happen to have already. Now let's take a look at this slide and let's think about it for a second. So let's try to model this screen as a state. This is now like the fundamental principle with which we can approach anything. And once we've done that, we can take this, we can redesign it, we can maybe a new design language comes through, we can change all the components out, but if the underlying state is the same, all we have to do is change the layout and everything will work correctly. This is one of the big advantages over something like MVVM over MVP, where your presenters are very heavily coupled to your UI. Okay, so here, let's see, I can tell you right now, we have a list of dogs. It's going to be async, and because we're going to fetch it from a repository of sorts. Then we have a details page, and on that page you can say, I love this dog. So we need to keep track of the dog that we currently love, and we need to make a request to actually adopt that dog. Okay, so let's go ahead and model this state. I'm just going to do it in this class so you can see it easily, or I'll do it in another class. Okay. So we're going to call it dog state, and we're going to make it a data class. So one thing I didn't show you before is that one of the very few things you have to do to implement MvRx in your app is to create a base view model. All you do is extend the base MvRx view model from the library and pass in one flag called debug mode. Now, debug mode will tell MvRx that you're running in debug mode, and it'll run a large variety of checks to ensure that you're using MvRx correctly. So it'll ensure that you're using a data class, so that things like hash code work really well. It'll even go through and check all your properties to make sure that they're immutable, and it'll even make sure that you're not cheating and saying that it's a list, but actually assigning it to something like an array list. It's really important that you go through the MvRx reducer to set state so that all the subscriptions and everything work correctly. All right, so now you know about the debug checks. So if I hadn't put data here, MvRx would have actually known and crashed. And what would happen is that the hash code and equals wouldn't be generated, and it would think that every single time we change the state, it's a fundamentally different object because it doesn't actually know. So we have data class dog state. As I mentioned, we have an asynchronous list of dogs. So file dogs, it's going to be async list of dog. In the wrong module here. Let's fix that. There we go. Okay, so val dogs, async list of dog, like that, and it's going to be on initialized. Awesome. Now we know that we need to be able to love a dog, just one. So we'll say val loved dog ID, and that's null. And then it's very important here that we're actually just saving the ID, because we have our list of dogs, and we can only love one of the dogs that we've actually fetched. So you'll see in a second, but we'll just store the ID, and then we'll use that to look up the actual dog. And then we'll say val adoption request, and that's going to be async of dog equals uninitialized. This is going to extend MvRx state. And now let's handle this love dog situation. So we know we're going to need a way to fetch a dog from our list of dogs. So we'll say fun dog ID long equals dogs. And so remember, this is the dogs is async of list. We can just invoke it. This will return nullable list of dogs. Now we can do !.find it.id equals dog ID. So let's see, yeah. I think that's, yep. So find already allows nullable. So now we have a function we can call in our state. So it's not just derived properties, we can create functions on it. This is also really good for testing. You can move a lot of logic into your test, and then you're literally just writing a unit test for an immutable data class, which is literally the easiest thing in the world. So now we have a val loved dog equals dog loved dog ID. And that's it. The entire state class, it's that simple. Let's go ahead and make the view model. So we're going to say class dog view model, and then dog state, initial state, just like before. Okay, so now we have an interesting situation. This one's new. We have something called a dog repository. And a dog repository is how we fetch the dogs, obviously. And we want to constructor inject it. That's really a nice way of creating our objects. It's also really, really good for testing. So let's go ahead and see what happens here. So we'll do private val dog repository. But here, MvRx doesn't know how to create your view model anymore. It knows how to make your state, but But if you give it other things, it doesn't know how to make that. Again, MvRx does not care how you do dependency injection. You can use Dagger or Coin or whatever you want. So it's flexible. So we can help it out here. Let's make a companion object, and we'll make it implement MvRx viewModel factory. Like this, and dog viewModel, dog state. So it's generic on the viewModel in the state, and there's one of two functions you can implement on it is called create. So this is a function that gives you two things: initial state and something called the viewModel context. Now, viewModel context gives you access to the scope of wherever your viewModel is trying to be created from. So if it's an activity viewModel, you'll get your activity and your application. If it's a fragment viewModel, in addition to those two, you will get the fragment it came from, fragment arguments it has, and those two. I'll show you fragment arguments in a second. So for the sake of simplicity for this demo, my dog application has a property called dog repository. Again, I've simplified DI, but you can definitely use this with Dagger. So let's get our application class or repository. So val dog repository equals viewModel context.app. App is generic to help you cast it to your application class easily. So dog application.dog repository. So again, I'm showing you this because it's simple, but you can integrate this with Dagger or whatever you want. And now we're going to return dog viewModel, state dog repository. Awesome. So this is what we need to create our viewModel. We haven't really done anything with it yet, but if we go ahead and build it, you'll see it should build, it's launching, and all it does is showing the loading screen because it doesn't know anything. We haven't done anything yet, except created our state, but we haven't wired it up yet. So let's go to our dog fragment, and we're going to do basically the same thing we just did with the counter. So the first thing we're going to do here is MvRx fragment. There we go. And this is going to tell us to overwrite and validate, just like that. So what we've done here is, let's see, we're using data binding to get started here. And if you've used data binding, it basically creates a binding adapter for any layout. And inside of it, fragment dogs. Android Studio is not liking it. Let's see if we just go ahead and restart Android Studio in the middle of the presentation if it becomes not red. That's nice. Basically, we have a bunch of stuff in our layout that just takes a state class. So the state class is the variable in our data binding layout. It binds all the state properties as needed. And then there's a second variable for click listeners, which we call handler. Okay. Let's see if it becomes not red this time. So I'll keep typing while this is indexing. Thank you, Android Studio. We're going to get a viewModel just like we just did. So we're going to do private val viewModel dog viewModel by fragment view, actually by activity view model. So here we know that we have multiple screens, so we're just going to jump straight to using an activity viewModel. Okay. And so basically here in invalidate, all we have to do is update the state for data binding. So we have to do with state viewModel state, and then we say bindings dot state equals state. Great. This is it. This is literally all you have to do to get your entire layout to respond to state changes. This would also be a good time to mention that you can have multiple viewModels in the same fragment. So you can do a viewModel like this, and then you just get essentially a generic form of this with multiple Lambda arguments. Okay, so that's about it. Now let's go back to our viewModel for a second and actually fetch these dogs. So we've created a dog repository, or we've injected it into our viewModel. So in init here, we're just going to call dog repository. Dog repository dot get dogs dot execute copy dogs equals it. One line of code. Let's go ahead and run that and see what happens. So again, this is execute from before. Dogs repository dot get dogs is an observable that will return a list of dogs after 2 seconds. And we're just setting dogs equals it, which is, let's see, 1, 2, boom, it worked. Awesome. So it's really that simple, one line of code, and this is lifecycle aware, both on the fragment side And inside of the view model, this will automatically be disposed correctly. Okay, awesome. So now we want to wire up this details page. Okay, so we have the dog detail fragment. Here we're going to do something kind of fun. Now, we know that we have to render a dog here, but which dog are we rendering? So we could store that in state, and then we would just call like selected dog or something like that. But maybe at some point in the future we'll add a carousel of dogs in the bottom. And then you might have multiple dog detail fragments in the backstack. So then what do? You have like you have to like understand the backstack of the UI. It gets really complicated. So instead of it being part of state, it's just going to be part of fragment arguments. So let's go ahead and do this. It's going to be a little bit magical, but we're going to say fun arg dog ID long equals bundle. So we're going to create fragment arguments here. Okay. And we're going to take this dog ID and we're going to put it in a very specific place. We're going to say put long MvRx dot key arg. This is a magic constant of sorts that MvRx knows about. And what you want to do is any arguments for your fragment, instead of having a bunch of individual bundle keys, you just have a single Kotlin parcelized data class. That's your arguments for your fragment, and you put them there. So we'll set it to dog ID. Great. Once you've done that, it's really easy to get it out. So we say private val dog ID long by args, like that. Now this delegate is going to look into your fragment arguments. It's going to pull out whatever you put into key arg, and it's going to cast it to whatever you tell it is here. So that's all you have to do. So now let's go to our dog fragment again. And to pass in arguments, this is navigation components. You can use whatever you want here, dog fragment, however you want to pass fragment arguments. So we have dog detail fragment dot arg dog.id. Great. Now in the dog detail fragment, we're going to rinse and repeat here. Things are going to start to look familiar because in MvRx there really aren't that many pieces to it, and everything kind of simplifies down to the same tasks. So here we're going to say invalidate with state view model, and then we have to get the view model. Private val view model dog view model by activity view model like that. Now we have the same view model, and we say bindings.dog. So here the layout for this fragment just takes a dog instead of the whole state, because that's all that it needs. So what we're going to do is this. So we're going to say dog equals state dot dog. So this is the function we created. Now we're going to do dog ID from the the property that we created by args. And you know what? If we get to this point and the dog doesn't exist, that's really not a good thing. We don't want to get there. So we'll just do error. This is part of the Kotlin standard library. Dog with ID. Dog ID doesn't exist. Great. Let's go ahead and run it. Again, this is the whole fragment. It's 40 lines with the imports, so you're talking 20, 25 lines. It's going to load, launch turbo. Now, one line of code, the entire details page just rendered with data binding, and it will react to any state changes. Let's say this observable repository is mapped to a room database. If the underlying data changes, this screen is just magically going to update, and when you go back to the previous one, it's also going to have the right data. So now, right now, this button down here, all it does is pop the backstack. So let's go to our view model and create a way to love a dog. So say fun love dog, dog ID, long equals set state, copy love dog equals dog ID. Great. So now we have a way, this is similar to the increment counter. We're just going to take the dog ID, save it to the love dog ID property. So in our dog detail fragment here, before we pop the backstack, we're going to say view model dot love dog dog ID. That's it. Now we can verify that this works. We'll go ahead and run it again. We say turbo, we say I love this dog, and now it says adopt turbo. If we say Pearl, whoop, not getting clicks. The clicks are gone. There we go. Now you love Jules, Pearl. Great. Now all we need to do is adopt a dog. We're almost done here. So we're going to say, go back to our view model, and we're going to say fun adopt dog, adopt loved dog. And then here, we want to adopt whatever dog we love. So we're going to do with state here, like that. And we're going to say dog repository, adopt dog, state, dot love dog, and then you haven't loved a dog. So again, this is just to help with nullability. You can't adopt a dog until you've loved it. So we're gonna execute this, copy adoption request equals it. So again, this is all we have to do, basically one line of code again to do that. And then we're gonna wire it up to the adoption fragment. So we're gonna do MvRx fragment, base MvRx fragment, beget invalidate, beget with state, view model, which we need to get. Check this out. It's going to come together quick. Get the view model, state, bindings dot dog equals state dot adoption request. And there we're just going to invoke the adoption request, which will give us nullable dog. That's how it will know if it's loaded or not. So go here, loaded, turbo, I love this dog, adopt turbo. It's going to take a few seconds, and hopefully when it's done, we will get the love dog here. We're getting really close. Getting close. And theoretically that works. So we're missing that one binding. I'm sure it's probably one line of code that it's not updating there. But this is all that it takes to get MvRx up and running. It's basically one line of code for a fragment. You can integrate it with any architecture you want. And I'm going to stick around after if you have any questions. But check out our repo. It's Airbnb MvRx on GitHub. And you can always find me on Twitter. My handle is gpeal8. Thank you.